Hi, I'm Steve Sobek, and this is lesson number 8 in a series of video lessons on how to use the TI-84 graphing calculator. The purpose of this lesson is to continue where we left off from lesson 7. We're talking about programming on the TI-84. We used a simple example in lesson 7, and we want to move on to a little bit more complex program in lesson 8. Our purpose for this program is to, we want to write a program that will solve quadratic equations. Given an equation that's in standard form, in the form of ax squared plus bx plus c equals 0, like these three equations down here are in, then our program is going to solve those for us very rapidly. And we understand that a, b, and c are real numbers with a not equal to 0. If a was a 0, then you would have no quadratic term and you would not have a quadratic equation. But b and c can both be 0. But the a, b, and c, these are real numbers, like 2, -5, and -3 would be your a, b, and c values. So given an equation in this form, our program is going to solve that if the user were to supply the values for a, b, and c. I'm assuming that you understand you've already solved quadratic equations with maybe 4 other methods. You've already solved using the factoring method. You've solved using completing the square method. You've solved using the quadratic formula. And you've solved using the graphing method. These are the 4 methods that we talk about a little bit throughout this lesson. If you want to get the most out of this lesson, you should already be familiar with those others. And then we're going to write the 5th method. We write a program to solve this for us. After we write our program, we're going to test it. We're going to test it with 3 different equations. Not 3 different random quadratic equations, but 3 different equations, because there are 3 different types of quadratic equations in terms of number of solutions. We can have a quadratic with 2 solutions, we could have a quadratic with 1 solution, or we could have a quadratic equation with no real solutions. And that's our focus, real solutions. We're not interested in the imaginary roots at this point. If you were, those of you who went through lesson number 3, where we were emphasizing the graphing method, it's most easy to see why those are the only 3 plausible scenarios that we can have. Remember that, say, the first equation here, the corresponding function that you would graph would be shown right here, and the graphical representation of any quadratic function is going to be parabolic in shape, and parabolas can only intersect the x-axis at most twice, as it does in this case right here. And remember that the solutions to this equation would be the zeros of this function. These x-coordinates are the points of intersection where this graph passes through the x-axis. And so a parabola could hit it twice. It's also possible for the parabola to hit the x-axis once, like right here. Here we have the x-axis is tangent to the parabola at the vertex point at 5, 0. We would say 5 is a double root. And it's possible that your parabola never intersects the x-axis, as in case number 3. And so those are the only 3 things that can happen. I mean, the parabola could be upside down, but still it can never intersect the x-axis more than twice. So those are the three different cases that we have. And to make sure that you understand exactly what our purpose of the program is, I wrote a program already. I'm going to run it so you could see it in action. And then we're going to start from scratch, create a new program, and go through all the coding to make that happen. All right, so I'm going to go over here to my calculator and hit the program button and execute program number 1. And It begins by giving a name of the program, which clues the user in as to the purpose, quadratic equation solver. They know that this is a program that's supposed to solve quadratic equations. All right? We want a user-friendly program, so it's nice to have a little information there. Furthermore, it displays ax squared plus bx plus c equals 0, so that later when it prompts us for the value of a, like it's doing right now, the user knows that, oh, a is that number in front of the x squared. Okay, it's the coefficient of the quadratic term, and b is the coefficient of the linear term, and c is the constant term. So it knows what we want. So we need this so that the user is not confused as to what information is required of them. All right, so on our first equation we had a 2 for the a value, a -5 for the b value. We'll type that in. And for c, we have a -3. And lo and behold, it shows the two solutions, 3 and -0.5, or -1/2, shown on two different lines. And so whenever we have an equation with two solutions, we want them to be displayed on two separate lines. That's all we need for that scenario. Now let's run this again, and let's use the second equation. Has a 1, -10, and 25. 1, -10, -10, and 25. And it shows the solution only once, even though that equation, if you were to use factoring method for that equation, that would factor into x minus 5 times x minus 5. If you set both factors equal to 0 and solve, you get +5, and you get +5 again. And students sometimes ask me, should we write on the answer line 5 twice, a 5, 5? And I would say no, that would be redundant. All right? But after your 5, why don't you put a d period r period for double root? So you'd be conveying to me that you understand that 5 is a double root. All right? And so that's what happens if we have one real solution. We want not only a 5, but we want this little message double root to appear after it. All right. Now, in the last case, we have coefficients of 1, 2, and 3. 1, enter, 2, enter, 3, enter. And it just displays a message, no real roots. And that's it. So that's what our program is to do. It's supposed to solve for the real roots of any quadratic equation. And you notice it does that very fast. All right, now let me clear the screen, and I'm going to begin the program. And I suggest that you try not to code along with me the first time you're watching the video. Try just to sit back and try to understand what I'm doing. You know, if I try to teach this as though you were trying to catch up, the movie would just be too long. So I'm just going to code it, explain what I'm doing along the way, and I want you just to sit back the first time through and just try to understand these the new control structure that we introduce in this program. And later, if you want to enter this program, you could run this through again and type it yourself. So to start a new program, I'm going to hit Program and highlight New. Choose number 1. It wants the name of that. Recall from lesson 7 that you have up to 8 characters that you could use in a program name. And the first character, you should start this with a letter, and the other 7 could be letters or digits. All right, so I'm going to go ahead and type a name. Okay, I've typed my name. I'm going to name this Quad Solve. If it allowed for 9 characters, I would have added an E to the end. All right, but remember that it was automatically an alpha lock, so you could just start typing the letters without hitting alpha Q, alpha U, alpha A, alpha D, because it knows that you want to type in characters. So let's I'll hit the Enter key to accept that name. It automatically puts me in edit mode. It is now waiting for my first command. Just like in lesson 7, I'd like to start by having my program clear the screen of any residual content that may have been there. So I'll hit the program button, and I/O is input output, and clear home is number 8. So hit that, hit enter, and that line of code will clear the screen. And now I wanted to have, to make it user-friendly, I needed to have the name of the program displayed and ax squared plus bx plus c equals 0 displayed. And then I'll begin to prompt the user to enter some input. So I'll use the display command. Again, that would be program, input output, display is number 3. And then I'm going to go into second alpha lock, and within double quotes I'm going to type in the message that I desire, which would be on the first line, quadratic equation, and on the second line, solver. Alright, so I'm going to pause it and type that in. Okay, I'll go ahead and hit the enter key, and that's the first line. Line 2 is going to be display solver. Alright, now line 3, we want to display the standard form, ax squared plus bx plus c equals 0. Program display, number 3 again. This time I'm not going to go into alpha lock because I'm going to need things like plus signs and equal signs, and you need to get out of alpha lock to access those characters. So I'm just going to tough it out and hit the alpha key anytime I need to type a letter. Ax squared, that'll be alpha a x raised to the 2 power. Okay, that would be ax squared. I might as well put alpha space, then a plus sign, alpha space bx, that would be alpha b times x, and then alpha space and a plus sign again, alpha space and an equal sign, a c, alpha c, alpha space, the equal sign. We access the equal sign through the test menu. That would be second math, second test. Number 1 is the equal sign. And then alpha space, and then a 0, and then alpha double quotes. And then we'll hit the enter key. When you're writing programs, it's not a good practice to edit, in other words, type in your entire program and then test it at the very end. If it's possible to test different modules or different segments, portions of your program independently before you're done with the whole thing, that is to your advantage. If there are mistakes, it's easier to correct them along the way than to try to find them when you're all done. Alright, so I'm going to stop at this point and just run the program. All it's supposed to do at this point is display a bunch of stuff. It doesn't do any calculations or display any answers, but let's see if it does what it's supposed to do so far. Alright, so I'm going to hit second quit, and then maybe just so I have some extraneous information on the screen to make sure, I'll test out my clear home. When it runs the program, it should clear out all of this garbage that's on the screen. Alright, so I'll hit program, and number 2 is, for me, number 2 is the name of that program, and I'll hit enter, and look, it cleared the screen, and it displayed the 3 lines that I desired. Quadratic equation solver, ax squared plus bx plus c equals 0. Perfect. That's exactly what I wanted so far. Alright, so let me clear the screen. Now to go back and edit a program that we've already created and begun coding, we're going to hit Program, highlight Edit, and then for me that would be program number 2. And I'm going to hit my down arrow key and get down here, and now we're going to begin to get some information from the user. We want the user to type in the coefficients, the values for A, B, and C. So to get, let's start with A. We're going to hit the Program button, hit the I/O, and input is number 1. Input, as you recall from lesson 7, allows you to first type a little prompt in quotation marks. So I'm going to hit alpha quotation marks and type in alpha A. Then I'll get my equal sign, second test number 1, and then alpha space, and then alpha double quotes, and then I'll put a comma, and then I need a variable that's going to hold the value of the quadratic coefficient. And we might as well use A. Remember, we have available to us any letter of the alphabet. We have 26 storage locations that we could use it in this situation. Why make it confusing? Might as well use an A to represent A. Alright, so we'll say alpha A and hit the Enter key. And when it executes that line, program execution will stop. We'll display A is equal to, and then the cursor will blink, and just wait for a user to type in a value and hit Enter. And then it will continue with program execution. Alright, same thing for B and C. Went back and typed in the command lines for the user to input the values of B and C. Let's do a quick, let's stop and run the program so far and see if it does what it's supposed to do at this point. Okay, all looks good. It allowed me to, it displayed what I had before, and it also prompted me and allowed me to type in 3 values for the for the coefficients. It doesn't do anything with them yet, but that's not what it's supposed to do. And we haven't coded that yet. All is well thus far. Let's proceed, go back into edit mode, program, edit. Number 2. And let's hit the down arrow. I'm going to hit the down arrow key, and I'm ready for a new line of code. We have different things happening based upon which of the 3 types of equations we have. I mean, they're all quadratic equations, but remember, quadratic equations fall into 3 categories. Scenario number 1, it has no solutions at all. Or another possibility would be it could have 2 solutions, and it could have 1 solution. All right, these are the 3 things that could happen. And so how do we know what situation we're in? Well, we know that for those of you who are right on top of your quadratic formula, we know how many real roots we're going to have based upon what happens in the quadratic formula underneath the square root symbol. We call that the radicand. And in this particular case, the radicand is called the discriminant. And that will, what happens there will clue us in as to which of the 3 cases we're in. If the discriminant is negative, you'll be square rooting a negative number, and that's not a real number. All right. Now that's an imaginary number, part of one of our complex numbers, and you could go into complex mode, and we could certainly calculate complex imaginary solutions, but that's not the purpose of this program. We're finding the real solutions. We're trying to make things simple and practical for your word problems that you'll be doing. There's the real solutions that the focus of your attention anyways. And so we need to calculate the discriminant. just the part inside. I'm going to go ahead and add a graphic down below here showing the quadratic formula. And so you'll be reminded that inside that square root you'll see, it's not there right now for me to see, but you will see it there later, b squared minus 4ac. And so let's calculate that. So we're going to type in, I'm going to type in b squared alpha b squared minus 4 alpha a alpha c. All right, that expression, when evaluated, will be the value of the discriminant. And I'm going to store that into a memory location. Might as well use something descriptive. It's representing the discriminant. Let's call it d, alpha d. All right, so now it knows the value of the discriminant. Then we want, based upon that, we have different things that's going to happen. And if certain conditions are not true, we want some of our lines of, like one of our lines of code is going to say no real roots. But we only want that line of code to be executed whenever there really are no real roots. So we have to be able to skip over code if that's not the case. And that requires that we introduce a new control structure called the if-then-end statement. If-then-end statement. Now I'm going to go ahead and type in the major parts of this and then begin to explain how this statement works. All right, we're going to access that from the program menu. CTL represents control structures, and then these codes we haven't used in lesson number 7. But these are branching statements and looping structures, and the one that we're going to use is if. So I'm going to choose number 1, and we're going to need to put a condition here. If the discriminant is negative, the d is less than 0. All right, so alpha d, less than symbol is also in our test menu. Second, test, less than is right here, number 5, okay, less than 0, enter, and we want what to happen. Okay, we need program, then, enter, and I'm going to go ahead and hit enter again, and I'm going to hit program, end, number 7. It doesn't end the program, that ends the if statement. Now here's how this if statement works. I wanted to have it typed in so you have something visual to look at as I talk about it. It's going to evaluate this expression. It knows the value of d. It already calculated that up above here in the line before it. And if it is true, then it will go down here and execute all the commands between the then and the end. We only need one line of code in this situation, but we're permitted to put as many lines of code as we want. It's unlimited. Your only limitation for the length of your program is the amount of memory that you have available. So I'm going to hit the up arrow key, and what is it that we want to happen if it knows that the discriminant is negative? Well, there are no real roots, so we want it to display no real roots. So program, IO, display, and I'm going to go into alpha lock and type in no real roots. Okay, as you can see, I've typed that in, and I'm ready now to move down to the next line of code. We're done with this. The if statement, the if then end statement is these 4 lines of code right here, and that statement is completed. If the discriminant is negative, it's going to execute this line of code right here, displaying no real roots, and that's all we need for that if statement. Now the other case, or one of the other cases, is what if the discriminant is positive. If D is greater than 0. Well, then we're going to have 2 row roots, and so some different stuff is going to happen in between the then and the end. So let's go ahead and get I'm going to get the if back in here. That's number 1. And hit enter. And I'll come back and put the condition in just a moment. And then program number 2. Then I'll skip a line and I'll put this end in here. Program 7 is end. And then let's go back and fill in the if statement. Hit the right arrow key. We need a condition here. And the condition, of course, that we want is if D is greater than 0. So alpha D greater than would be second test. Greater than is number 3. And 0. And hit the down arrow key to get down here. Our condition is good. Now, what's going to happen down in here? Well, we have 2 solutions, and again, I'm going to display the quadratic formula, and you recall that the quadratic formula reads opposite b plus or minus the square root of b squared minus 4ac all over 2a. Now, the plus or minus, as you recall, it doesn't mean I can't make up my mind whether to add or subtract. It means you do it twice. You do it once with an addition sign to get one of your solutions, and then we do it once with a subtraction sign to get the other. All right, so let's get the first one using the addition sign. So in parentheses, we're going to type in opposite b. Again, here's your negative sign down here below the 3. Don't use the subtraction sign for a negative sign. All right, opposite b, alpha b, plus the square root, that would be second, right above the x squared key is the square root. The square root of, I could type in b squared minus 4ac, as most of you are anticipating me to type in. But remember that we've already evaluated that expression and stored the result in memory variable d, so we can have our program a little bit more concise if we just put a d here, alpha d, and close the parenthesis, and it will be square rooting. Having the d here would be the same as having a b squared minus 4ac. All right, let's close the numerator parenthesis, and then divide that by, in parentheses, 2 alpha a. Now that expression, when evaluated, will yield one of the 2 real solutions, and we don't want that solution to go off into oblivion. We have to do something with it. We're going to store that into a memory location. Let's see, we've used variables a, b, c, and d. Let's use e. Store is right here, and alpha e, and hit the enter key, and then second insert, enter, gives us another blank line up here, and we'll type the same thing with a subtraction sign. Okay, I finished typing in the second line with the minus sign instead of the plus sign. I've used memory variable f to store that value. Now the calculator knows the 2 solutions. They're secretly being held in memory locations E and F. We now need to force the program to display those values. So let's, I'll hit the enter key, and second insert, enter, and get the up arrow key. So we need a display command. That would be program, input output, display is number 3, and alpha E. I could have 2 lines of code, display E on one line, display F on the other, but it is permissible to type in E comma F, and it will display those 2 values on 2 separate lines. And that's all that we want to happen if D is greater than 0. It's going to display those 2 real solutions. So we're good with that case. All right, we've taken care of two cases so far. The case where d is negative and thus has no real roots. The case where d is greater than 0, where we have two real roots. The only case left is what happens if the discriminant is equal to 0. All right, let's hit the Enter key and let's type in program if, and let me save the condition for later and go down here and get our then, and skip a line and go to number 7, end. Okay, so we kind of have the structure. We always need a if, then, and end, and then we can go back and type in the condition and type in all the lines of code that we need in between the then and the end. But I want to stop and run the program at this time, just because I understand, I know that there's a mistake. There's a missing condition. That's called a syntax error. As we're in edit mode, the calculator does not check for syntax errors. And so eventually it's going to happen to you as a programmer. You're going to get this error message on the screen, and I don't want you to spaz out because you're unprepared for this. We are going to force that to happen. So we're going to look at that error statement and then show you what to do with it when it happens. So I'm going to hit second quit, and I'm going to run the program, and I'll type in some values, say 1, enter, 2, enter, 3, enter, and look at this. Just as I warned you, we got an error statement, an argument error. Okay, an argument is something that you're supposed to type in after the word if. We have two options. We could quit, just go back to the home screen, and maybe tomorrow we'll go back and look at the code and try to find the mistake. Or we can go to where that mistake occurs. Well, I prefer that, and then at least I know which line has the problem. So I'm going to type in a 2, and bang, it opens up the program in edit mode and goes straight to the line that has the difficulty. That's this if statement with a missing condition. And I'm ready now to hit my right arrow key and type in the missing condition. All right, that would be d is equal to 0, alpha d. Second test, number 1 is equal to 0. And let me go down here between the then and the end. And now what's going to happen if the discriminant is 0? There's only one solution. Well, we need to calculate that one solution. Up here we could see these two expressions. What expression should we use? The one that we stored in E or the one we stored in F? Either one. Because remember that the discriminant is 0 and the square root of 0 is 0. So whether you add 0 or subtract 0, you're going to get the same answer with both of these. All right? Just like if you were using factoring method, to solve an equation with one solution, like the x minus 5 times the x minus 5, and in both cases you get positive 5. All right, and so we could type in either one of these. I'll type in the top one with a plus sign, but let me pause it and type that in. Okay, I have that expression typed in. And I should mention too that if you wanted to just omit this little section here, since the square root of 0 is going to be 0 in here, we could have just typed in opposite b all over all this stuff. Okay, but I'm going to leave it here just so that no one's confused thinking that I'm using something other than the quadratic. I'm still using the quadratic formula, and because people are watching what I'm doing, I don't want to confuse them. I'm going to leave that just as it was up here. All right, I'll hit the enter key, and then second insert enter to get a blank line up here, And recall too that whenever we have one solution, we wanted to have a little message saying double root. So to display that, we'll hit Program, IO, display is number 3, and within double quotes, we're going to type in double root. Okay, I finished typing in that message. I also should mention that for those students who have had exposure to programming before, as we looked at those menus and you saw those control structures and you saw the if, the else structure, and you may be wondering, well, why did we not use nested if statements or extended if statements with the else structure? Wouldn't that be more efficient? And I don't blame you for wanting to use those, but remember that this program already is more complex than our Lesson 7 program, and I want to keep it as simple as it can be and yet still accomplish our purpose. And so using these consecutive if statements, I think, is easier for new programmers to understand, and that's why I did that. That now completes our program. We've taken care of all the different cases. You know, this discriminant being negative, we took care of it. We have an if statement to take care of a positive value for D, and we now finally have an if statement here that will take care of a 0 value for D. We need to go back to the home screen, and let me clear it up, and we're going to test it with all 3 equations to make sure that all the parts of the program are operating correctly. All right, so the first equation had coefficients of 2, -5, and -3. So let me run this program. 2, -5 for B, -3 for C, and it solved it, gave us the answers, 3 and -0.5, or -1/2. All right, run it again. And for the second equation, we have 1, -10, and 25 are the three coefficients. 1, -10, and +25. Oh, look at this. It said double root, but it did not display the root. I forgot to display the E. All right, well, that's why we test our programs. All right, let's stop right what we're doing and jump back into Program, Edit, number 2, and let's run down there and find the location of that. Now your TI-84 calculator can detect syntax errors, and you'll get error statements. But if you make calculation errors or logical errors, it's not going to detect that. You know, if you use the quadratic formula and divided, instead of by 2a, you divide it by 3a, your calculator doesn't know that you muffed up. It's going to display the wrong answers and just give you what you asked for. All right, so you have to test your answers, make sure, use equations that you know the answers to, so that you can verify that it's producing the proper output. All right, let's go down here to where we had the double root. Okay, right here. And let's second insert, enter, hit the up arrow key, and to display the value of E, we want display IO, number 3, and we want to display alpha E. All right, let's go back to the home screen again and run the program. And for our second equation, we have a 1 x squared. We have a -10 in front of the x, -10. And our constant term would be 25. And good. Now we can see we not only know that there's just a double root, one solitary real solution, but we know what it is. We've displayed it. Okay, so I'm glad that came up. Okay, that's the purpose of testing. All right, and we're not done testing. We haven't tested scenario number 3. What happens if the discriminant is, what if we have no solutions at all? So that would be the third equation. So let's run the program again and use coefficients 1, 2, and 3. Okay, 1x squared plus 2x plus 3 equals 0 would be that equation. And there's our message, no real roots. Success. All right, so now we've created a new program, we've entered the code, and we've tested it, a program that will solve quadratic equations, that will just prompt the user for the coefficients of A, B, and C, and spit out the answer, the real solution. So that's pretty neat. It took a little bit of time to code that program in, but now quadratic equations can be knocked off lickety-split. That's pretty powerful, using programming to your advantage. All right, let me pause this. All right, in this video, the last thing I want to cover is how do you delete a program that you no longer want. To do this, we're going to go into memory management, second mem, see the MEM right above the plus sign down here, and memory management would be number 2, and this will allow us to delete programs. All right, so I'm going to choose number 2, and I'm concerned about the number 7, the program. So I'll hit number 7, and here's a list of all my programs. I could use my up and down arrow keys to highlight the program that I don't want, and I could hit this delete key, and it will prompt me, are you sure you want to do this, yes or no? Now if I wanted to delete it, I would choose yes, but I want to show you one other thing, so I'm going to choose no for now. The other thing that you can do with programs, suppose you have a whole lot of programs, maybe not all that you've typed. You know, you could your calculator came with a cord to allow you to connect your calculator to another TI-84 calculator, and you could transfer programs. And maybe you've transferred several programs onto your computer that you never use, or you haven't used, but you're not sure whether you might need it down the road in the future. You could free up some of your RAM by archiving a program. To archive a program, you point to it, like suppose this program that I wrote yesterday, I want to archive that. Just hit the enter key, and a little asterisk appears beside the name of that program. Then if I hit second quit, go back to the home screen, and hit the program button, I will no longer be able to run this archived program. If I choose number 1 to run this, I get an error. Okay, it's been archived. You can't run it. So it's not accessible, but it's also not deleted. It's still there. I could go back and unarchive it the same way I archived it. That's just another option. So now you know how to create programs, you know how to delete programs, you know how to archive programs. And I think that's the main things that we want to cover in this particular video. With what I've shown you in these 2 lessons, Lesson 7 and Lesson 8 on programming, you could do a ton of stuff. You could write a lot of very, very useful and powerful programs just with those commands that you've seen me demonstrate. But you've also noticed in those the control menu and the input-output menu that there's a lot of other commands that we didn't cover, and that we don't have time to cover. We don't want to make these videos too long. People wouldn't watch them if they were. If I were to, I'm considering the possibility of starting an online Algebra 1 or Algebra 2 class using webinar software. So students would see me, see my whiteboard, and see the calculator, and and we would just be able to, students would be able to talk and everyone could hear them, and they could even, show their video too, but that wouldn't be mandatory. But they would feel like they're right in the classroom. They could ask questions by clicking a certain button. And it would be a very interactive type of class, almost like a real classroom, as if you were all in the same room. I haven't decided whether to do that yet. If I do, and if you like the programming, then perhaps consider enrolling in one of those Algebra 1 or Algebra 2 classes, and we can get into some of those other commands. Programming is neat. It can come in very handy, and these, even if it's not on the calculator, these concepts can be applied with other programming language, Java and Visual Basic, or scripting, JavaScript or server-side scripting, and ASP. There's a lot of places that programming can come in handy for you, and I think it would be worthwhile. And if I decide to run one of those classes, we'll get into more detail. But for this series, I think we're going to wrap up programming, and I hope you enjoyed that, and I hope you could see the potential that you have being able to program with your TI-84 calculator.